Good morning everyone. Today in this live lecture we shall study, we shall discuss, we shall learn the integration of, how to find out the integration of sine raised to 2m minus 1 into cos raised to 2n minus 1 with respect to x in the form of a gamma function. That means we have to express this integral in the form of gamma function. There is one important theorem based on this. We shall prove that theorem and then we shall solve the problems based on this actually. Okay. Now here this is our today's lecture, which is based on integration of sine raised to 2m minus 1 into cos raised to 2n minus 1 into x in terms of a gamma function. Okay. And then later on we shall move towards the double integral, triple integral. Okay. Now see this is the definition of the gamma function. We can write gamma function in the different form which we have studied already. These are the important notes and relation, basic properties of gamma function. These are the transformations of gamma functions. Okay. Now this is the main theorem, that is gamma 1 by 2 is equals to root pi, which we have studied in the previous lecture. Also we have discussed a beta function. Beta function is defined as integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. So we can write this beta function in the another integral form with respect to y, with respect to t. This is the evaluation of a beta function in the form of a factorial. We can prove, we have proved already m and n are the symmetrical in the beta function. So this is the transformation of a beta function. We can transform the beta function in this way also. Integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to 1 minute. Okay. Beta m comma n integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n. This is the transformation of a beta function, and some properties also we have seen in the last lecture. Also we have seen the relation between gamma and beta function in the last lecture. Okay. So now we shall move towards the solution based on this. Okay. Now actually we have seen, what we have seen, I shall write that property here, property number 16. 1 minute. In the last lecture we have seen what is that property. I am going to write here 16. Beta m comma n, which is equals to gamma m into gamma n divided by gamma of m plus n. This is a very important relation which we have studied already. Now you can write the note number 17, that is beta of m comma n, which is equals to beta of n comma m, that is a symmetrical. Also we have proved one important relation, gamma n into gamma 1 minus n, which is equals to pi divided by sin n pi. Already we have proved these properties. So also 19, also we have proved there is one important property, that is gamma of n plus 1 into gamma of 1 minus n, which is equals to, it is easy to write in this way, 1 plus n. So we can write n pi divided by sin of n pi. See this is very important relation. And also the very important transformation of the gamma function is, beta function is beta of m comma n, which is equals to integral from 0 to infinity x raised to m plus 1 divided by 1 plus x raised to m plus n dx. So it has the same, we can write this is also same as integral from 0 to infinity x raised to n n m minus 1. So n minus 1 divided by 1 plus x raised to m plus n dx. This is the important transformation of the beta function. That means up till 20, these are the basic 20 formulas related to the beta and gamma function. Now today we shall discuss the another important formula for the beta and gamma function, that is the important theorem we shall discuss, okay? Chala students, now write down theorem. This is a very important theorem. For all m and n are positive, for all positive values of m and n, comma, they are integer or fractional, means it may be integer, it may be fraction. Then prove that integral from 0 to pi by 2 sine raised to m t. मग तुम्हाला हा फॉर्म्युला कशात लिहावा लागला असता? टी मध्ये लिहावा लागला असता, लक्षात घ्या. टी मध्ये फॉर्म्युला लिहावा लागला असता. म्हणून तुम्ही काय करा, थीटा मध्ये प्रॉब्लेम घ्या. सो इंटिग्रल फ्रॉम 0 टू पाय बाय 2 sin raised to 2m minus 1 into theta into cos raised to 2n minus 1 into theta d theta, which is equals to, काय प्रूव्ह करायचं तुम्हाला, which is equals to gamma of 2n minus 1 1 minute. See this. Actually, we have to prove this theorem. This is a very important theorem. What is that theorem? For all positive values of m and n, which are integer or fractional, then we have to prove integral from 0 to pi by 2 sin raised to 2m minus 1 theta into cos raised to 2n minus 1 theta d theta, which is equals to gamma m into gamma n divided by 2 times of gamma m plus n. Actually, if we check the right side, then some part of the right side is equivalent to the beta function. Beta of m comma n is equals to, we can relate it in the form of, how we can relate it in the form of beta m plus n is equals to gamma m into beta m comma n is equals to gamma m into gamma n divided by gamma m plus n. If we check the right side, then you will be get the definitely say that it is the part of a beta function. So we have to start proof of this theorem, which is based on the beta function. So we can write, we have beta of m comma n is equals to integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. Check this. Here is x, but we have to prove in the trigonometric function. Here is the integration with respect to x. We have taken, but we have to prove this result in the trigonometric function. So it is essential to substitute this integral in the form of a trigonometric function in such a way that here we need sine square, 2 raised to m minus 1 means sine square, it is starting with square. So approximately put x is equals to sine square theta. So put x is equals to sine square theta. Is it okay? So we can write dx is equals to 2 sin theta into sin theta derivative cos theta with respect to theta. Again we can change the limits. If there is a definite integral, then after the substitution of a limit we have to put the value of a limit. Okay, what is that limits here? Lower limit is for x is equals to, when x is equals to 0, then sin theta is equals to 0, sin square theta is equals to 0. That means sin theta is equals to 0, that gives answer as a theta is equals to 0. And upper limit when x is equals to 1, then if we put x is equals to 1 in the substitution, then 1 is equals to sin square theta. So sin square theta is equals to 1, sin theta is equals to 1, that means sin theta is equals to pi by 2, because the value for the sin pi by 2 is equals to 1. So now our new integration, new form of integration becomes, how we can write? Beta of m comma n, which is equals to, very good, Hamid Sheikh, Sainath Seware, Shraddha Dukre, Survase, Reddy, Kasre, Bhosle, Madina. Okay, so integral from 0 to pi by 2. Now we have to replace x as a sin square theta in equation 1. So sin square theta bracket square raised to m minus 1 into cos 1 minus, again there is a 1 minus x, x means sin square theta, so we can write 1 minus sin square theta bracket raised to n minus 1, and dx means 2 sin theta into cos theta d theta. This is the complete substitution. Now we have to solve this integral from 0 to pi by 2. We can write sin theta raised to 2m minus 2. We have to use the index rule. A raised to m, its power n, then we can write a raised to mn. In this way, sin square theta and its m minus 1 means sin raised to 2m minus 2. Again here 1 minus sin square theta, we can use the identity, standard identity, cos square theta raised to n minus 1 into 2 sin theta into cos theta d theta. So here we can take integration, out of integration 2. See this, we can take out of integration 2. So we can write sin theta raised to 2m minus 2 into this sin theta we can take here, that means sin theta. Again we can write cos square theta bracket raised to n minus 2 means cos theta bracket raised to 2n minus 2 into cos theta d theta. So that will be 2 times of pi by 2. Okay, integral from 0 to pi by 2, sin theta raised to 2m minus 2 into sin theta means sin theta raised to 2m minus 2 plus 1, that will be sin raised to 2m minus 1 theta into cos raised to same process 2n minus 1 into theta d theta. This is the beta of m comma n. See this is suppose equation number 1. This is equation number 2. Now we have, there is identity that is, we can compare the beta function and gamma function. There is a relation between, we have, what is that identity? Beta of m comma n, which is equals to gamma m into gamma n divided by gamma of m plus n, gamma of m plus n. Very good. Aishwarya Nade, Madiha, Mane, Shraddha, Hamid, Manvi, Ekurke, very good. Aditya Reddy. Okay, now suppose this is equation number 3. Now observe equation 2 and equation 3 having a left sides are same, so we can write the right sides. So from 2 and 3 we can write gamma m into gamma n divided by gamma of m plus n, which is equals to 2 times of integral from 0 to pi by 2 sine raised to 2m minus 1 theta into cos raised to 2m minus 1 theta into d theta. But we have to calculate it. We have to prove integral from 0 to pi by 2 sine raised to 2m minus 1 theta cos raised to 2n minus 1 theta d theta. That means we have to prove this result. So now we can take here. Now we can take these two. We have to transfer these two on left side, then we will get the required proof. Therefore, we can write, how we can write? Integral from 0 to pi by 2 sine raised to 2m minus 1 theta into cos raised to 2m minus 1 theta d theta, that can be written as gamma m into gamma n divided by 2 times of gamma m plus n. Okay, and hence proved. And hence proved. In this way, we can prove this important result. We can prove this important result. Now we can deduce this result. We can reduce this result in the particular form. So I can write the deduction. So deduction. How we can write? Number one, you know that first integral from 0 to pi by 2 sine raised to 2m minus 1 x dx into cos raised to 2n minus 1 x dx. Is it okay? So that can be written as a gamma m into gamma n divided by 2 times of gamma m plus n. स्टुडंट, हा थेरम तुम्हाला समजला का रे? हा थेरम तुम्हाला समजला का? हां, इथं बाय मिस्टेक n झालेला आहे. ओके, आय शॅल राईट दिस n 2n minus 1. Is it okay? If you have any doubt, writing mistake, sometimes when I am going to teaching here, then we have to manage all these things. We have to check yourself, you have to check monitors, you have to check writing pads, keypad, camera, focus, we have to check also screen, and many times due to the handling of these many terms at a time, then sometimes it may be possibility to make writing mistake here. There should be writing mistake, then you can verify that writing mistake. You can verify that writing mistake and you have to write in the chat box, then I will be correct that. Okay, it is your duty also. Okay, and also due to this writing mistakes, I shall check, are you concentrated on the teaching here, on the video lecture or not? It is also visible from you. Okay, so you have to check this. And hence proved. If you have any doubt, then you can ask me. This is a very simple theorem. Only we have to write the beta function, and in that beta function put x is equals to sine square theta, then dx, then calculate the new limits and substitute the value. We have to use the beta and relation between beta and gamma function, then solve this. This is very simple theorem. Then also if you have any doubt, then you can ask me. Okay, so we shall make the deductions. Now second deduction, put 2m minus 1 is equals to p, 2n minus 1 is equals to q. Therefore m is equals to p plus 1 divided by 2, n is equals to q plus 1 divided by 2. So we can write this formula in the form, so integral from 0 to pi by 2 sine raised to p dx into cos raised to q dx. That means we have to replace this for the problem solution purpose. This formula number 1 is for the purpose of a theorem, solution of the theorem, purpose of the solution of the theorem. So we can put this for the purpose of a solution of the problem, we can write that formula. So sine raised to p dx into cos raised to q dx, sine raised to px, because we have substituted 2m minus 1 dx. So cos raised to 2n minus 1 means qx dx. Then we have to replace right side also, gamma of p plus 1 divided by 2, gamma of q plus 1 divided by 2, total divided by 2 times of gamma of p plus 1 divided by 2 plus q plus 1 divided by 2. Then we will get the result. This result we can same written as, see this, p plus 1, q plus 1 means p plus q plus 2 divided by 2. So we can write this formula in this way also, or we can write in this way also. Formula number 3, this is a very important deduction for the problem solution purpose. We can write integral from 0 to pi by 2 sine raised to mx into cos raised to nx dx. Then we can write m into gamma of m plus 1 divided by 2, same process, into gamma of n plus 1 divided by 2 upon same, in replace p by m, q by n on both sides. Then we will get gamma of m plus n plus 2 divided by 2. See this is a very important formula to prove the result. Again we can write this, we can modify this formula for integral from 0 to pi by 2 sine raised to m x dx. Then here in this case we have to consider cos raised to 0, that is n is equals to 0. Then how we can write this formula, that is a gamma. That means same formula by putting n is equals to 0, because sine raised to m into cos raised to n. N means we have to put the 0. So gamma of m plus 1 divided by 2 into gamma of, if we put n is equals to 0, then 1 by 2, that means its value will be root pi upon, again we have to put n is equals to 2, so 2 times of gamma of m plus 2 divided by 2. In this way we can write, इथं लिहा वाटलं तर since n is equals to 2. अगर इस तरह का प्रॉब्लम होता है sin raised to m dx or cos raised to m dx, then we have to put n is equals to 0 and we have to use same process, same formula here. Okay, now let us start the problems based on this. हे डिडक्शन्स आहेत. हा फॉर्म्युला वेगवेगळ्या मॉडिफाईड फॉर्म मध्ये कसा लिहिला. ॲक्च्युअली दिस इज आवर थेरम, बट फॉर द प्रॉब्लेम सोल्यूशन पर्पज वी कॅन राईट दिस theorem, proof of the theorem in the some standard form in which we can compare the problems, we can solve the problems easily. So we have reduced deductions of this standard forms. We can use this, we can write this, or we can write this, we can write this. Okay, now we shall solve the problems based on this. नाव चेक दिस. हां ठीक आहे. आता इथं हा लिहित असताना महत्त्वाचं म्हणजे इथं लिहित असताना हा जो अनादर फॉर्म आहे ना, ही कंडिशन लिहित असताना महत्त्वाची कंडिशन इथं ब्रॅकेटमध्ये लिहा. काय कंडिशन आहे पहा. वी कॅन राईट द कंडिशन m इज ग्रेटर दॅन -1, n इज ग्रेटर दॅन -1 बिकॉज m इज अ पॉझिटिव्ह. If we consider m is a positive, that means greater than 0. If we put n is equals to 0, then also p is greater than -1. So you can take m is greater than -1, n is greater than -1. For this formula, p is greater than -1. याचा मीनिंग कसं होतो. 2m - 1 is equals to p. या फॉर्म्युल्यामध्ये m and n पॉझिटिव्ह इंटिजर होतील. परंतु इथं जर रिप्लेस केला p मध्ये, इफ वी रिप्लेस दिस फॉर्म्युला इन टर्म्स ऑफ p और इन टर्म्स ऑफ n, then there is a condition. What is that condition? m is greater than n minus 1. So I shall write here. Okay, I shall write 1 minute. वाटलं तर तुम्हाला लिहा. इथं कंडिशन लिहू शकता. What is that condition? Here कंडिशन फॉर्म्युला 3rd नंबर फॉर्म्युल्याची कंडिशन आहे m greater than m, n ग्रेटर दॅन -1. हे पण सेम m, n नाहीच आहे, m ग्रेटर दॅन -1. बट इन द फर्स्ट फॉर्म्युला व्हॉट इज दॅट कंडिशन? m, n ग्रेटर दॅन 0. हे कंडिशन्स फक्त लक्षात ठेवा. ओके, नाउ वी शॅल सॉल्व द प्रॉब्लेम्स बेस्ड ऑन दिस. इज इट ओके? बरोबर आहे का सर्वांना? काही अडचण आली, इफ यू हॅव एनी डाऊट देन यू कॅन आस्क. लगेच चॅट बॉक्समध्ये तुम्ही लिहित चला, तर तुम्ही ते सॉल्व करत जाऊ. ओके, नेक्स्ट वी शॅल मूव टुवर्ड्स दिस 1 minute प्रॉब्लेम्स. हाऊ वी कॅन राईट? सी दिस. नंबर 1, प्रूव्ह दॅट integral from 0 to pi by 2 sine raised to m theta, sine raised to 4 theta into cos raised to 2 theta d theta, which is equals to pi by 32. Is it okay? So given that किंवा लेट असं करू, लेट we have to prove this result. That means we have to calculate the value of this integral is equals to pi by 32. Let I is equals to integral from 0 to pi by 2 sine raised to 4 theta into cos square theta d theta. Suppose this is 1. Now we have to write the formula integral from 0 to pi by 2 sine raised to mx into cos raised to nx dx. What is that formula, student? Gamma of m plus 1 divided by 2 gamma of n plus 1 divided by 2 upon 2 times of gamma of m plus n plus 2 divided by 2. So we have to use this formula here. Important 3 number 3 formula. So here m is equals to 4, n is equals to 2. Therefore our integral becomes I is equals to gamma of 4 plus 1 divided by 2 gamma of 2 plus 1 divided by 2 upon 2 times of gamma of 4 plus 2 plus 2 divided by 2. Is it okay? Yes, very nice. We have to use the third formula. I is equals to the value that is gamma 5 by 2 into gamma of 3 by 2 divided by gamma of, what is that value? Gamma of 6, 8 by 2 means 4. 2 times of gamma 4. Is it okay, students? Now you know that we have calculated the value of gamma 5 by 2. चला रे calculate केलेली value सांगा. Yesterday we have already calculated this value gamma 5 by 2. How we can calculate here? I am going to write here. Gamma 5 by 2, that can be written as, okay, I shall write here. Gamma 5 by 2 means gamma n means n minus 1 factorial means 3 by 2 into gamma 3 by 2. Gamma 3 by 2 means 1 by 2, again gamma 1 by 2, into gamma 3 by 2 means 1 by 2, gamma 1 by 2, divide by 2 times of 4 means it will be the 3 factorial. So it will be the 3 by 4 root pi. Gamma 1 by 2 means root pi. 1 by 2 into root pi divide by 2 into 3 factorial means we can write 6. That means root pi into root pi, that will be the pi. 3 into pi divide by 4 into 2 into 2 into 6. 3 1 the 3, 3 2 the 6, then final answer is pi by 4 into 2 means 8, 8 into 2 means 16, 16 into 2 means 32, so pi by 32. Hence we can write therefore integral from 0 to pi by 2 sine raised to 4 theta cos square theta d theta, and hence proved. Is it okay? समजलं का तुम्हाला हा? Yes. Now we shall move towards the next problem. Next, second. Evaluate integral from 0 to pi by 2 sine raised to 6 theta d theta. Is it okay? Very good, very good. Madina Karbari, Sunil, Hamid, Omkar, Radha Birazdar, Akanksha, Salunke Pranjali, very nice. So we have to prove this same as like this. We have to use this formula or you can use this formula. Okay, there is no any problem. So let I is equals to integral from 0 to pi by 6 sine raised to 6 sine raised to 6 theta d theta pi by 2, sorry, pi by 2. Integral from 0 to pi by 2, we can write sine raised to 6 theta into cos raised to 0 theta d theta. That means here m is equals to 6, n is equals to 0. So we can use this formula again, formula number 3. This is a very interesting and important formula which is the deduction of this theorem. This theorem we have deduced this to for the purpose of the solution of the problems. Okay, so we have to put m is equals to m6. Okay, so use that formula. So I is equals to integration of, what is that formula? Gamma of m plus 1 divided by 2, 6 plus 1 divided by 2 into gamma of n plus, n means 0 plus 1, 0 plus 1 divided by 2 upon, या फॉर्म्युल्यामध्ये आपण 0 वापरू शकतो. We can use in this formula m or n is equals to 0 because for this formula we have the condition m comma n greater than -1. -1 पेक्षा मोठा कुठलाही चालतो. So we can use 0 also. That means divide by 2 times of gamma of m means 6 plus, what is that, 0 plus 2 divided by 2. Is it okay? So calculate this value. That means gamma of 7 by 2 into gamma 1 by 2 divided by 2 times of gamma 4. Is it okay? So now we can write this I is equals to 7 by 2 minus 1. Actually gamma n, that means n minus 1 factorial, means 7 minus 1 factorial. 7 minus 1 factorial means we can write 5 by 2. So 5 by 2 into 3 by 2 into 1 by 2 gamma 1 by 2. This is the value of gamma 7 by 2 into gamma 1 by 2. It is as it is because we have to put the standard value of gamma 1 by 2. 2 times of 4 factorial means we can write n minus 1 means 3 factorial. So 15 by 8 root pi into root pi divided by 2 into 6. So 15 pi divided by 8 into 2 into 6. 3 5 the 15, 3 2 the 6. So 5 pi divided by, we can write this as a 32. So I is equals to this. Hence integral from 0 to pi by 2 sine raised to 6 theta d theta, we can write 5 pi by 32. So this is a very important. Why we can write, why we can say the gamma function and beta functions are important? Because we can solve such types of integrations. We can solve such types of integration. Unless we have to use reduction formulae for sine and cos, and that was the very lengthy process which we have seen in the previous lecture, in the previous chapter. Okay, so no problem. Now next we shall move towards the next problem. Integration of third. Prove that integration from 0 to pi by 4 cos 2 theta bracket raised to 3 by 2 into cos theta d theta, which is equals to 3 pi divided by 16 root 2. Is it okay? Now we have to prove this result. Answer: let I is equals to integral from 0 to pi by 4 cos 2 theta bracket raised to 3 by 2 into cos theta d theta. Okay, but here we need, actually here we need cos 2 theta, but according to our theorem we need only sin theta and cos theta. In this form we can't use cos 2 theta, so we have to replace this cos theta by using the trigonometric identity. What is that identity? Cos 2 theta is equals to 1 minus 2 sin square theta. This is the identity, this is the formula for cos theta. So we can write this integral from 0 to pi by 4 1 minus 2 sin square theta bracket raised to 3 by 2 into cos theta d theta. So we can use this formula here. Cos 2 theta means 1 minus 2 sin square theta. Is it okay? But we can write this also, integral from 0 to pi by 4 in a bracket 1 minus, I shall write this, we have to adjust 1 minus root 2 into sin theta bracket square whole to the power 3 by 2 into cos theta d theta. See here we need only here cos sin theta. Here we need only sin theta. So for this purpose we need here sin theta. We have to replace only sin x. Root 2 sin theta we can replace sin x, because in the standard form we need only sin raised to m cos raised to n. So we have to convert this total bracket into the sin. How we can convert? By using the proper substitution. We can write this, put, suppose this is I, put, suppose this is 1, put root 2 sin theta which is equals to sin x. That will be sin square x. So we can write 1 minus sin square x. That will be cos square x. There is no problem. So if we differentiate, then root 2i is it is sin theta चा डेरिवेटिव तो cos theta d theta which is equals to sin x चा डेरिवेटिव तो cos x dx. Cos x dx. So we can write this cos theta d theta. Check this integration. There is a term cos theta d theta. So we can write cos theta d theta, which will be 1 upon root 2 into cos x dx. Also, to use this standard formula, we need limits 0 to pi by 2. But actually in this problem we have given the limit 0 to 4. So we can write this 46. 1 minute. Okay. 1 minute. So I shall take some. So there we have to this substitution. Now we have to also change the limit, because we need 0 to pi by 2. When limits, how we can change? See this, when the lower limit is x is equals to 0, or sorry, theta is equals to 0. If we put here root 2 into sin theta means sin 0 means 0. That means sin x is equals to 0. That will be x is equals to 0. When theta is equals to 0, then x is 0. Also when theta is equals to pi by 4. See this, put the upper limit here. Sin theta means sin pi by 4 theta, root 2 into sin pi by 4, which is equals to sin x. What is the value of sin pi by 4, student? Sin pi by 4 means 1 by root 2. Root 2 will be get cancelled. 1 is equals to sin x. Then x is equals to pi by 2. So we will get new limit, that is a x is equals to pi by 2. Therefore our integration becomes I is equals to integration from 0 to pi by 2, 1 minus, now root 2 sin theta we have replaced as a sin x and its square, bracket raised to 3 by 2 into, again here, cos theta d theta, we can write 1 by root 2 cos x dx. 1 by root 2 cos x dx. So I is equals to integral from 0 to pi by 2. 1 minus sin square theta means cos square x, bracket raised to 3 by 2. We can take, okay, root 2 into cos x dx. So I can take root 2 out of this integral from 0 to pi by 2. So we can write cos square x, bracket raised to 3 means cos cube x, into cos x dx. That means I is equals to 1 by root 2 integral from 0 to pi by 2. we can write this as a cos raised to 4x dx. Is it okay? Cos raised to 4x dx. Now we can write this in the form of I is equals to 1 by root 2 integral from 0 to pi by 2. Actually there is a absence of a sine term. So we can take sine raised to m in this way. Sine raised to 0 x into cos raised to 4x dx. So we can write here m is equals to 0, n is equals to 4. Then we can write I is equals to 1 by root 2. You can use the formula gamma of 0 plus 1 by 2 into gamma, n means 4. 4 plus 1 by 2 divided by 2 times of gamma of 0 plus 4 plus 2 divided by 2. Is it okay, students? Yes, I is equals to 1. 4 plus 2 means 6. 6 divided by 2 means 3 factorial. Gamma 3 means 2 factorial. So I can write that is 2 into 2 factorial means 2. That will be root pi into 3 by 4 into root pi divided by 4 root 2. That means root pi into root pi, 3 root pi divided by 4 into root 2. So 3 root pi divided by 16 root 2. So this is I. Hence integral from 0 to pi by 4 cos 2 theta raised to 3 by 2 into cos theta d theta is, which is equals to 3 root pi, 3 pi. Is it okay? 3 pi. Root pi into root pi means 3 pi upon, we can write 16 root 2 and hence proved. And hence proved. अशा पद्धतीनं हे प्रॉब्लेम होतात. ओके. आता या टाईपचे तुम्हाला सोल्युशनला मी होमवर्कला देतो, तुम्ही होमवर्क करा. होमवर्क फर्स्ट इंटिग्रल फ्रॉम 0 टू पाय बाय 2 sin raised to 5x into cos raised to 4x dx. Second integral from 0 to pi by 2 sin raised to 4x into cos raised to 6x dx. Third integral from 0 to pi by 2 sin raised to 8 theta d theta. Fourth integral from 0 to pi by 2 cos raised to 7 theta d theta. Okay. Now you have to solve all these 4 problems. Okay. तर सर्वांनी हे प्रॉब्लेम सेम पद्धतीने सॉल्व करा. नाउ वी शॅल स्टॉप हियर. नमस्कार. गुड.